Hey everyone, how's it going? So fun one today. We're gonna mix it up. As you can tell, still working this whole thing out. It's been a while since I've been doing this regular, but I really wanted to get back into it because I think it's a ton of fun. And what today's stream is all about is fun. I was having a discussion yesterday with somebody that I very much respect and admire. And one of the things that we were talking about was that a lot of the fun seems to have been pulled out of a lot of what we're doing. So everything's, very, very serious. People aren't making like customized websites anymore. There's a lot of this, yes, we've matured, technology's matured, but there's still a lot of amazing things that we can do and a lot of fun that we can have. And for me, that's actually one of the best ways that I learn is by having fun. So that's the goal of today's stream. We're going to do a tiny cloud project. So instead of building something big and massive, so the last couple streams we were looking at a side project that I'm building up, and we selected a serverless database for that project. We went with Firestore, been experimenting with that in the background, and that's really working out well. Very pleased with that choice, and I'll do a video or a live stream updating that project when it gets a little further along. But what I want to do today was just a tiny cloud project. Just something really, really simple and really fun. And what that comes from is actually the idea for today's project came from Apple's big event. So they released iOS 15. If you haven't updated already, you can go to settings and then general and software update. You have to scroll down a bit to hit 15 because 14 is still available. But now you have the ability to do live text on the camera. Android's had this forever, but for now with iPhones, you can actually point your camera at something. It will highlight the text and you can copy that text right out. I think that's super handy, very useful. Already been using it a bunch, but I want it on my Mac. Just because. Am I going to use it all the time? Probably not. Am I going to use it every once in a while? Yes, I will. So let's build it on the Mac. It's not available here yet. That's hopefully coming in Monterey. I think I didn't even bother to check. Figured this would be a fun little project. We're going to use Google Cloud. We're going to make a Python based command line interface application, so a CLI application that we can type in the terminal, and that will take an image and return the text back from it. Now, we're gonna use a couple Google services for that, cloud storage, which I've used a bunch before, and the Vision API, which I don't think I've actually used before. So it's gonna be a learning experience for both of us. Expect some mistakes. I'm gonna make mistakes. And if you're in the chat live here, feel free to point them out politely, constructively, and we will work on it together. That's the whole point of this. So I'm going to flip over to my second monitor and let's give that a go. And let's give that a go. And all right, over here, this is the Apple Secure. This is the Apple what it is. It's very simple. When you're in the camera, you can actually highlight the text. You can actually highlight the text. You can actually highlight the text. Oh, there we go. That should do it. Thanks, Christopher. Much appreciated. I think that'll do it because the system audio was kicking in. Let me know if that resolved it. So what I was saying is we've got this Vision client libraries, haven't used them before, hoping that is going to do what we want to do. Let me just double check that. Yeah, perfect. Thank you, Christopher. Very much appreciated. So just to recap what I was saying when my audio was garbled, because I assume the system audio was echoing in twice because I've been playing around with the setup, experimenting with all this stuff. We're going to use the Google Vision API to take an image and do OCR on it and then return that result back to us. Very, very simple, very straightforward. We could use Amazon Textract for this. I believe Azure has a service as well. Just happened to pick the Google Cloud because I've never used it before. So I thought this was a great way to learn. I have done a little bit of homework ahead of time. Let me show you in our text editor here. So I have already gone through and created a new project in my Google Cloud account. I've created a Tiny Cloud Projects project, and I've created a service role and set up the permissions locally on my system. So they are currently in the, you get a JSON file for your service role permissions, and I've added that into my environment variable for the command line. So anything we run from that command line will use those credentials and leverage the Tiny Cloud project. So I set that up. That is available in every single quick start in the Google Cloud. It walks you through doing those steps, so I didn't bother to repeat them here on stream. Similarly, I've gone into Google Cloud Storage and I've created a new bucket. That bucket is just TCP data, not that TCP, in this case, Tiny Cloud Projects data. And then I also installed the relevant Python library. So the way that the API, the SDK works for Google Cloud, for Python specifically, when you install it, it doesn't install all the modules for all the different services. You have to call those out specifically. So I installed storage and I installed Vision. I also have a little bit of plumbing pre-written. I'll walk you through that right now. I'll copy that up. There we go. Okay, so very simple. Plumbing already created. I have a function that uploads a file to the Google Cloud bucket. That's how the Vision API works. It has to pull the image from Google Cloud storage. So I've already created a function that will take an image file path and a bucket name and push that file up into the Google Cloud. Haven't tested it as much as I should. Hopefully that works. We'll see. Similarly, I've also made a function that's going to copy any text you pass to it into the Mac OS clipboard. That is a brutal hack and it's ugly and I don't want to show you, but I will. Basically, we're just using a sub process to open up the PB copy utility. There are third-party Python libraries that do this in a much more graceful manner, but I didn't want to go there. This is just a quick and easy kind of hack that we can smooth out later if this becomes a project that we use all the time. And then I added, the last thing was I added the argument parser for Python already. So this is the way to pass command line arguments in a nicer way than just the sysarg variable. So here we've got a -i for input. That's going to be the file name to the image, and then -c if we want to actually copy to the clipboard. So just a little bit of plumbing to make that a little bit smoother experience as opposed to walking through that skeleton code. So let's flip back to the browser for a second. Now that we know what we want to do, we want to take an image file and we want to push it into the Google Cloud. Let's see what happens here with the Vision client libraries. We're going to go down to Python reference. Yikes, that is ugly. Okay, let's go back. Let's hide back and go and scroll down. So we've already set up authentication. We've already installed the library. So if we click on Python, we're going to see here very straightforward. I love how they clearly comment things. Google Cloud Import Vision. We've already got that in our script. We've already installed that module in the background. So we need to create a client, which is vision.imageAnnotator client. That is going to automatically use the credentials that are in our environment variable that we've already set up. Seems very straightforward. If we get a image, we can annotate that. So we've got an image, they actually load the path, okay, and then they read the bytes of the image into memory, and then they actually pass it directly into that. So they aren't actually using it from Google Storage. That's interesting. When I read the initial docs, just doing a tiny bit of research, it was like, oh, you need to pull it from Google storage, which makes sense. You dump everything into the bucket and push it over. But in this case, we're actually just reading the bytes and then pushing it as an object up. And then what we're seeing is they're creating an image from the Vision library and then performing label detection on that image file and then responding with those labels. Okay, let's just copy this. And, security me is always like, don't copy code from the internet. Realistic me is Google's not going to put something horrendously inappropriate sitting there. So let's copy this into our project. Good old Python. We're going to make sure that we've got the indents properly set up. And now we've got the same kind of thing. We've got our Vision client installed with the image annotator client. We've got the absolute path. In this case, we don't actually have to do this. What we can do is go args.input, which is up here is the argument. parser is going to drop it into a variable called input, or an attribute called input on the args object. So very simple, very straightforward. We've got our file name there. We're going to open up that file name as an image file and then read it into content and then pass it to the vision object as an image, and then read those labels back. So let's give it a shot. You know, I don't live code really ever. So let's see if this is going to work. Let's clear this off and make life easier for you. All right, we're going to go into dev tiny cloud projects, and we are going to go Python live text and -i, and then I have a bunch of test images in here from the California streaming event that Apple held a little while ago. So let me see their iPad mini specs. That's a complicated one. iPad OS, I guess. There we go. Okay, so these are screenshots from the Apple live stream. In this case, this is one that is just a big black text with a big black screen with Tim Cook in front of it, and the big single bold as can be letters of iPad OS. So let's see if that's actually detected with our code. And of course I made an error. That didn't take long, did it? So let's flip back, line 31. I forgot something stupid. So this is rule number 1 of coding. It's always something dumb. It's always something dumb. You know, when I talk to young coders who are like, hey, what should I be doing? How can I get better? You're going to make mistakes. This is case in point. I'm putting myself out here, live code in front of you. We're going to make a lot of dumb errors. I hope they're all dumb errors, because when they're complicated errors, those are the ones that you really have to pay attention for, and you have to figure out like, hey, you've done something wrong here, just missing a semicolon, missing an indent, stuff like that. No big deal. Okay. So IO is not defined. Here's another dumb error. I forgot. So when I copy and paste the code in, they have another standard module in place, in this case IO for input output. Just going to add that in, resave the file and rerun it. And now we get a really good exception. So now we're into the meat of this. We've stopped making dumb mistakes, and now we're going to get big mistakes. So here, what we've got is GPC. Okay, so this is a Google Cloud. This first line, I'm using Homebrew, obviously, because I want to use a modern version of Python. In our core, Google Remote Procedure Call Helpers is having a problem. Now, what is that problem? Permission denied. This is the fun part. So by default, in all the clouds, you're not allowed to do anything. So here is another, here's a great example of a good error code. The Cloud Vision API has not been used in this project, that's my project number, before, and it is disabled. Enable it by visiting this URL. Now, by default, unlike in AWS or in Azure, you need to remember that Google, I'm just going to copy that URL, that by default, Google Cloud's APIs, not only do you not have permission to use them, they are actually off. They just turn them straight up off. I actually don't mind that. I think that's a pretty positive security model. But in cases like this, when you're like, oh, I'm going to try out a new API, you get hit by these kind of errors. So when we paste in that error message, the URL from that error message, right out of the bat, Cloud Vision API, it needs to be enabled. We've never enabled it before. So we're going to enable it. It's going to take just a second. And now when we rerun our code, once this is enabled, it should be okay unless we're going to hit a permissions error. Okay, so let's try that again. Let's clear that off to make life easier. So I'm just going to clear the screen, then rerun that with our image. And boom. Okay, so this is now actually giving us the annotation label. So we're using the wrong part of the Vision API. And that's one thing that I noticed off the bat with the Google API is that it does a whole bunch of things from one place. So I'm going to show you that image, what it actually returns. So this is the image, very straightforward, Tim Cook in front of a big screen. This is iPad OS, and there's a little bit of lighting in the corner. And what Google thought that was is flash photography, sleeve gesture. So this is Tim's shirt, font, big font, entertainment, performing arts. So it figured out that it was some sort of event, darkness, electric blue, and there was some level of branding. So it was Apple's branding that distinct that it actually pulls up an image recognition. So the good news is we were able to actually use the API, pass it an image, and return what we wanted. The bad news is, or I shouldn't say what we wanted, the bad news is we didn't get what we wanted. We got the image annotations, which was right in the name. I mean, honestly, I should have caught that. It was right in the name. It's image annotations. We don't want image annotations. What we actually want is we want the OCR version. So let's see if we can dig in. And again, it keeps taking me to this ugly documentation. So I'm going back and I want to see the quick start. We're going to look for not the vision or in the vision API, but we're looking for different samples. What we want is we don't want to annotate, we want to OCR. So we're going to scroll through all the annotation. We don't want to do, there we go, detect handwritten text. Detect handwritten text in a cloud storage file. So we're going to look for a local file because then we can skip that cloud storage step. That would be nice. Let's dive in here and let's hope that this is the same one. So detect handwritten OCR, so optical character recognition. That's far more in line with what we want to be doing. And let's see, it's the same kind of thing. In this case, it's the image annotation client. But what is the difference here? It's image context. Okay. And then client text detection. Okay, so we're getting a bit of a difference here, and then we're getting a way more complicated response back. So in our initial code, we were just getting one thing back, and it was very straightforward, just a list of elements, and I'm sure there's other metadata associated with the confidence of that elements. But in this case, we're obviously getting something that's significantly more complicated back. But we do have the same setup here, which is great. So the Vision API does the same kind of thing. The difference is, let's copy this over. Image context, it gives a language hint. So in this case, English, something handwritten, I assume. We probably should read the docs, but man, this is the fun of live streaming and live coding. We're not going to bother. We're just going to keep plugging away. Client document text detection. Okay. And then image with the image context. Okay, so let's see what we can do. Let's copy this over and we'll update our code. So we'll go back to Sublime, and we know here we're going to shrink this, and we know that this works fine, the image annotator client. Let's verify that that's the same client we want, just to double check. Image annotator client's fine, up to the vision image, right up to the point where we make an image object, we're okay. So everything above line 71, totally okay. What we don't want to do is this one. Label detection is not what we want. So let's get rid of this, even though it's beautifully simple. And let's get into something more complicated. In this case, we're creating a custom context. So vision into image context language hints. Let's find the right language hint, because then what we're doing is making a call to the document text detection with our image and the appropriate context. So we've made a custom context. Let's see if we can Google that for Google Cloud Vision API language hint. OCR language, there we go. Okay, language hint, language supports. We're looking for supported languages, great. Care about that. What I want is the actual hint. So this is the good old times when we actually just copy that specific field and we're going to Google back. Again, I told you I hadn't used this service ahead of time. So we are going to look at different ways. There we go. This might be where we want. Document text detection. Okay, so now we're in here, text detection. This is what we're trying to do. This is exactly what we're trying to do. So let's scroll down and we will find out what that potential hint is. So here, text annotations, text context, text. Okay, so we don't even have to do that. We've got a simpler version here. Let's do this, which is kind of cool. So let's flip back over. And we are going to get rid of this context. We're going to go to the image right there. So we don't want to do handwritten. Handwritten seems more complicated. We're going to do client text detection, and we're just going to pass it an image. That image is created the same way. So we've pulled all the bytes off the local file and we shoved it into an image object. And now we're going to get text response. From this response, we're going to get text annotations. And then for each one of those, we're actually going to spit it out. And then we actually get the vertices. So the vertices are going to most likely tell us where in the image we found them. So let's just make sure we get rid of all the ridiculous indent issues. So that's fine for vertex and vertices. So that's one big line, isn't it? There, that should be fine. Okay, so we're gonna save this and we're gonna do it again. So we're gonna pass it the same image, and instead of getting the annotations of what it is, we should actually get the text back, hopefully. Hey, there it is. Sweet. Okay, that's always nice. Success is nice. Now it's got iPad OS, and then it gives us the boundaries of where. Now we're gonna play with that in a second, because I would absolutely love, switching back to my browser, I would actually love to be able to generate images that actually highlight where the text was found. And the API is actually giving us back that information already, which is excellent. So let me just switch back to my code. So you see here, we've got, we're printing the text. That's great. What we're actually gonna do is we're gonna strip that too, just to make it a little bit cleaner. And then we've got the vertices, so we can actually use that in a few minutes. Let's rerun that, and we should get a little bit clearer. Yeah, so now we just get iPad OS. But what if we send it the mini specs? So this image, I'll flip to my preview here. This image has a bunch of text on it, and it's really tiny. So you can see here, we've got the little callouts for each product thing. We've got this 5G, which is highly stylized. We've got some gradient 40% with labeling underneath it. So we've got a wide variety of text on here. I'm really curious to see how this reacts in this case. So let's run it through. And boom, there we go. Okay, so here we've got a bunch of the text that's coming out from there. So if we scroll back up to the top, here's what it found. It found smart folio covers, Touch ID, USB-C, liquid retina display. The 5G, that's interesting. So that's our first little error, and that's okay. Is that the 5G, where it's got that sort of echoing appearance to it because it's highly stylized, it's interpreted that as exclamation marks. And that's not unreasonable. But it did pull out all the text from all appearances. So that's solid. And again, then we get them in individual callouts, and then we get the boundary conditions for each of them. Now the boundary conditions are far less than I would expect for those individual callouts. It seems to be, now either this code by default is shrinking it down, or we're not calling out specifically enough. What it seems to be giving is just like almost the entirety of the image, which is not super useful, but we'll deal with that. We're actually having a ton of success here. So there's another one I wanted to see. This was from the ridiculous workout, get ready for snow season. As a Canadian, I can tell you, you're never ready for snow season. It's just not a thing. It just happens, and you have to deal with it. But let's see what if it can pull out this text. So we're looking for the time. We're looking for Fitness Plus workout programs. And then I was really curious to see if it could get this very hard to read Anya Garcia at the bottom. So we're gonna pass it this one. This is streaming Fitness Plus. And then we'll see Apple, no, that's the A15 specs, Fitness Plus. Okay, so let's see what that pulls back for us. Oh, wow. Okay, so it did hit Anya Garcia. It pulled a 6 from somewhere, 6 episodes at the bottom, sure. So again, it pulled everything we were looking for. There's the clock, 10:09, Fitness Plus, workout programs, super smooth, super easy, and it's got the line, get ready for snow season with gold medalist Ted Ligety and Anya Garcia, 6 episodes. So this first chunk of text that we're pulling out is in fact as it appears in the image. Very straightforward. So let's actually accomplish our goal here. When we say print texts, it goes text for text and it lines that up, and then it gives us the vertices with the boundary. So if we comment that out real quick, I just want to see how clean it's coming back. So it's still giving us the individual. So I'm looking where is the first, I'm wondering if the first returned is all of the text, and then the rest are the individual callouts. So let's quickly comment this out and just go print texts 0. So the first image in that array, or the first string in that array, and we'll see what we get there. We don't, ooh, okay. So that is actually everything. And that array is all of the findings for that. So we get more detailed vertices. So that's what we were missing last time, is that way the default tutorial's pushing that out. It's crunching down and losing some of that data, but the description attribute has what we want. So let's pull that out. text0.description.strip to make that clean. And this should be all the text that it found in the image. Okay. Boom. Okay, so we need to comment out the vertices because we didn't comment that out all the way, but it is pulling out what we actually want. So let's comment that. Now, what we're going to do is, the reason why we did this is going to be our result. So if we say result is this, now we've got all the text from that image, and we're going to go back up and we're going to use our copy to clipboard text feature. And we're going to try and see if that works. Copy to clipboard, results. Okay, so we've isolated just the first returned result, which is all of the text in the image. We've stripped it down to get rid of the trailing and leading new lines, and we've now passed it to our function to copy to the clipboard. Let's see if that works. So we're going to clear it. We're going to run it again. It might have. Let's see. If we come back in here, sorry, let's paste. Nope. Nope. Did not function. So the question is, what's wrong in here? Now, this is using a lovely little sub-process hack in order to do that, which, it's not great, but it should get the job done. Because basically what we're doing is we're just piping that text into PB copy, which is the pasteboard copy, and we're sending it the text, and then we're closing it up, and then we're returning a true result. So let's elaborate on this, if just in case. Print error. Now, this is a horrible thing. You should never do this, is we're just dumping the error out just to see, because we were hiding it before, which is also a horrible thing that you should never do. But we're just hacking this together. So a byte-like object is required, not a string. So if we go back and go Python, convert string to bytes, I can never remember. Good old Stack Overflow is always the top answer. Yes, accept all the cookies. Let's scroll down and see what potential answers are. If it's a string, byte array, and then we convert it over to string encode. Yeah, okay. I don't like these super verbose answers, ironically enough. I just want something straightforward. So converting string to bytes. Bytes is string. Yeah, okay, that makes simple sense, right? We're just taking the bytes function and we're passing it a string. So let's go here and we're going to say text. Super simple. We'll try it again. No error, always positive. And if we flip back, let's go and paste it in here. There it is. Nice and easy. So we've already accomplished our goal. What we've done is we've set it up and we've run an image that we pass, and we return back all the results and we put them into the clipboard. So if we did have an option for that though, so what we're going to do is we're going to say if the argument -c was provided, then we are going to do that. So if args copy to clipboard, then we're going to copy it to the clipboard. So that's just a nice little thing, is if we do -c, it's going to copy to clipboard. Otherwise, it's only going to output it to the command line. And we're going to clear this error messages up, this header up. There we go. Okay, so now it's going to look a little bit better. And we're going to run one more quick test, because if I flip to my Finder, we have we did the iPad OS, we did this one. We haven't done this. I thought this was really interesting. In the bottom right corner, in a really hard to read, tiny text, is all the details of the camera configuration that was used to take this photo. So we're going to try that one, that sample photo. Similarly, I want to pull out the A15 specs. So we're going to do the A15 specs first. We're going to see that. That should work no problem. And then we'll do the more detailed photo one. So if we go A15, and yeah, there. So we have a new error again, text found in this A15. It thinks the apple is a C with a tiny diacritic on the top. Again, totally reasonable. But then we've got the 2 high performance cores, 4 efficiency cores, faster neural engine, okay, so these are all the features of the A15 in text. So why is this handy? I do a lot of screenshots when I'm watching live streamed events, so that I can tweet them out and provide commentary on social media. Well, now I can also run it through and get the text immediately instead of retyping it. And this is pretty fast. Like if we look at that, that's a pretty fast return, right? That's sub 2 seconds without a problem. So that's a really positive thing. That'll actually help my workflow, especially because we skipped the step of going from the cloud storage, so Google Cloud Storage. The good news there is also we don't have images that are sitting in our Google Cloud Storage that we're paying for. Sure, it'd be negligible, but we'd have to clean those up and delete them and things like that. But let's run our last test before we wind this down. Let's run with the sample photo. Now it had that tiny text in the corner. Let's see what it's got. So here, perfect. Again, this is working flawlessly. This is excellent. It's an iPhone 13 Pro, ultra wide lens. Here's the focal length. It was shot by Ryan Carruthers in LA. The exposure time, the F number, ISO 32. No wonder that photo looks amazing. It was shot at ISO 32 with a f1.8. So that's the photo right there. Looks fantastic. It's shot on the ultra wide as using it like a portrait lens, so it's get a bit of a fisheye, get an elongation. Very, very cool. So that's it. Very simple. We've created using some of these resources that we found very, very quickly. We were able to create an application running from the command line that leverages this cloud service. Now, the last question I want to wrap up on is pricing. So for Google Cloud Vision API OCR, and pricing. Always good to add pricing in there. So pricing for Cloud Vision. Here we go. Document text detected is what we're doing. Perform OCR text. Yes. How much does this cost? Tell me the prices. Document text detection for first 1,000 units per month is perpetually free. So if you don't use this more than 1,000 times in a month, you're actually not going to pay anything. And then for the next 1,000 units, up to 5 million, you're going to pay $1.50 for 1,000. And I believe they fractionally price that. But basically, if you keep this under 1,000 calls per month, you can actually use the entire API. So we know it does handwriting detection. We know it does label detection, which we already did as well. It tells you what's in there. But we also have safe search, so it's looking for explicit stuff, facial detection, landmark, logo, all that kind of stuff. So this is a great API, and at 1,000 units a month, that's a pretty robust usage. Now, I would blow through that with 2 live events, but at $1.50 for the next 1,000, to keep this for under $1.50 for a month is pretty powerful. So what I'll do is I'll post the links here. I'll post the code up into probably into a gist because it's not that complicated, maybe into a GitHub for tiny cloud projects. We'll see, but I'll put this on the blog as well, markn.ca. Let me flip back to me. We'll go here and we'll just thank you for tuning in. This was a little tiny cloud project. We replicated the functionality of Apple's live text. What I'm going to do for fun now is actually figure out how to take those vertices that were returned and draw those images using PIL, the Python image library, on top of the actual image that we passed. So I want it to highlight the text where it found it. Should not be super complicated because PIL has a polygon feature where you can actually just push through all the specific polygons that you want and it will draw them up. So very simple. In 25-30 minutes here, what we did was we created a command line application that takes an image, sends it up to the Google Cloud Vision API, and that returns all of the text that is in that image. And if we pass the -C, it copies it into the clipboard, just like live text on iOS and iPadOS. That'll hold me over until Monterey has it. And probably this is going to be more useful than that as well, because I can chain it together with that script I used to take those screenshots in the first place. Super handy. I think there's a ton of opportunities for little tiny projects like this. There is no reason we shouldn't be having a ton of fun building in the cloud. There is all these amazing tools. It's not, if you use it under 1,000 times a month, it's zero cost. $1.50 for the next 1,000 after that. There's no excuse not to be playing around with this stuff, learning, improving your skill set. Thank you for joining me. I very much appreciate it, and we'll see you in the next one.